Like how does it tie in? Oh, okay. I think any collection of files that create some like software product, or it could be a front end, like it could be like the HTML files that are responsible for it. It could even be like code to interact with a database, like you might. Yeah, I'd say so. Like a collection of files where things are interconnected. I would say that's like a function.
So us learning right now, like if I understand that, so like explain like how would you explain this class?
No, that's a good question. I think it might be we have like a okay, I'll have to think about it because resume is like 1 bullet point, 2 bullet points, right?
Yeah,
that's a great question.
You want to just say like what are we doing?
Yeah.
I know working with
yeah, I think you want to change the program comprehension and like teamwork kind of, but yeah, it's like workflow and information management. I don't know exactly what the right term is.
So we got something.
Yeah. Oh, these are distracting?
Yeah.
Okay. Do people find these things distracting, or would y'all prefer having them down? We're just trying this out this lecture. We can totally move them up. Raise your hand if you want me to move them back up. Okay. Raise your hand if you want me to keep them down. Okay. It's pretty even. I'm not sure.
I don't know where to go.
So
They're all the same.
I know, but like it's just.
Okay.
is it cool to just do them like I don't know if you can get that.
Oh yeah, we could do just for them. Is this one distracting maybe?
Yeah.
Okay, let's do that. Okay, sure. Let's go with this.
Oh my god.
I'm not even sure if that one's okay, let's go ahead and get started today, everyone. I have a new game that we're going to try out. It's called Worldle, okay? Just like Wordle, but there's an extra L in there for like the world, okay? So hopefully nobody was able to like see this coming and already find out what the solution is today. The way this works is we have like a country outline and then we have to guess the country and then it'll give us, I think, some hints for how close we are and then we have to do it within 6 guesses, okay? So, anybody like know the outline of this? Do you have an idea? Poland. Good guess. Wow, that's crazy. Okay, we got it in one. Good work, everybody. Good work, Steven. Okay, we'll try this game out. Sometimes it's really obvious, though. We can do another one. Oh, you know what? You can do this. Neighbors. You get 7 neighbors of Poland.
Germany.
Germany, yeah.
Germany and German.
Denmark.
Okay, anyway, this is a game y'all can play it on your own. We're gonna move on now, alright? Okay, so let's go ahead and start. It looks like that projector's not working, but if people do have, preferences with those side things, let me know. We've turned the lights off, and we'll keep it like this throughout the lecture, so the lights will be on there, they'll be off here, and then we won't change it for the lecture. Okay, so I went over the feedback that everyone gave. I think we had like 35 responses last time I checked. Just to be clear, you can still submit the feedback form like today or tomorrow. You're gonna need the little passphrase at the end of the reflection survey, of the feedback survey, to submit the exploration activity that we're gonna talk about today. But I went over every single question, every answer, and there were a few takeaways. In general, though, the feedback was good, so I was at least happy to hear in general things are going well. Couple issues though. One was pacing of the class. This one, we actually got like extremely kind of mixed answers. Most people think the pacing is going well. There's some people that think it's going a little bit slower. Some people think it's going a little bit faster. Based on like reading people's actual like open-ended responses, I've sort of come to an understanding of why we're seeing this. I think the people that said it's going a little slow, this might not be 100% accurate for everyone, but maybe the lectures were going a bit slow, and admittedly last lecture we did slow down with like the debugger setup. And then some people were saying that the activities go a little bit too fast, like there's not enough time to actually think through the problem and discuss with someone else. So I think that may be responsible for a couple of the, the answers in the 2 and 4. I mean, in general, like with teaching in class, you're not going to make everybody happy. Some people are going to feel like it's a little slow. Some people might feel it's a bit fast. We'll do our best to sort of manage this, but just a heads up that this was kind of the feedback that we saw, and so maybe that can help you understand sort of the decisions that we're going to be making, like going forward for the class. Okay, a couple of people mentioned knowing what to expect in lectures and the assignment schedule. I agree with this. I think one thing that I did since last lecture is if you look on the syllabus now, or on the schedule, we have like the tentative plan for almost all of the lectures. There's a couple of TBDs in there. But we also have all the deadlines and our plan for when we're going to release everything, okay? So also, for those of you saying that the class is going a bit slow, I want to just point out that I think the start is a bit slower than the end, but if you look through all the stuff in the milestones, I guess project milestones, there's going to be a lot that is happening in the last like 5-6 weeks of the class in terms of the work that y'all will be doing outside of class, okay? So keep in mind that the beginning part of this class, we want to teach you a lot of these important techniques for you to effectively go and do all these different projects. So with because I released this schedule, I also want one takeaway to be that try to start work early on these projects. I know when like an instructor says that, it's like at the end of the day, it's when the assignment is due that maybe a lot of people will work on it. But when you look through the schedule, each week there might be 1 to 2 things that are due, so getting ahead of it will definitely help, okay? Yeah, there's also a couple of interesting points about are we just learning things that are specific to VS Code, or is this something that also applies to other IDEs that you might use in industry or outside of VS Code? And yeah, the goal of this is to teach you sort of things that are generic to a lot of IDEs, okay? So if you work on PyCharm or IntelliJ, a lot of these have the exact same features of code navigation, you being able to use extensions that contribute to whatever specific project you're working on. So just want to sort of alleviate that concern. And then there were some interesting topics people said that they wanted to hear more about. I listed them out here. We're going to try to get to those by the end of the quarter, okay? All right, so I mentioned the assignment schedule. Project 2 overview. Remember, I released Project 2 on Tuesday. There's a Project 2 checkpoint, okay? So on Tuesday, this upcoming Tuesday, 1 week from when we release the assignment, you're going to have to submit a pull request that's just showing the progress you've made so far on Project 2, and you'll need to include a diagram and sort of a description of your plan of approach, okay? So we're going to go over diagramming today, so you'll have the tools to be able to do that, but make sure you at least have some progress. We'll give some feedback, and if you're completely stuck, we'll give some guidance as well. And if you want to just finish it by this upcoming Tuesday, feel free to go ahead.
What if you finish before then?
Say that
What
again.
if you finish it before then?
Yeah, you can turn it in then. Yeah.
Do we still need to do the checkpoint?
No, in the checkpoint, you'll just submit it. It'll just be Project 2 done. You can put that in the title of the pull request. If you want to submit it you can submit it at any time, but just make sure to indicate that it's done if it's going to be before the Project 2 checkpoint. Okay, for Project 1, we're going through the reviews right now. We should be having gotten back to a lot of you right now. If you haven't, don't worry, our internal goal is to have these all done by tomorrow. But don't go ahead and merge. We'll do the merging. All the course staff will actually be the ones responsible for merging your project branches into your main branch, okay? And we'll only do that after we give feedback and you respond to the feedback, and then we're happy with the changes, okay? You can go ahead and start Project 2 because it'll be on a separate branch, and there won't be any merge conflicts because your project 1 will be making changes to setup.md, and in project 2 you'll be working on a different set of files. Are there just any questions with this project 2 checkpoint? I'm going to give more directions about project 2 checkpoint later, but just any questions with this right now? Okay, cool. Just a couple more things to point out. Let me delete these two, so we just went over it. So you can take a closer look at the schedule, but very soon we're going to release the group project proposal assignment, and you'll also be like getting in teams as part of this, and eventually in week 9, you're gonna have code walkthrough presentations, okay? So what you have to do for the group project is you'll get in teams of 4, and in the proposal, you'll have to propose 2 new features that you're gonna add to idle, okay? So you'll brainstorm with your group and come up with like a feasibility plan, some design documents about how you plan to do it. As a course staff, we're gonna look over all of them and sort of tell you which one we think would be better for you to go with, okay? So just start thinking about that now. You'll want to get in groups of 4, and then that same team that you're with is what you'll do for the code walkthrough presentations. The code walkthrough presentations are later in the course. I'll definitely give more instructions, but you'll be doing an actual like presentation on a part of the idle code base using the techniques that we've gone over in class, okay? So just keep that in mind, that this is going to be like, you know, a constant part of the class starting next week, where you'll also be having this overall group project to work on. Any questions there? Okay, awesome. So I want to finish going over the debugger, and it was, I think from the feedback, it was good that a lot of people said that they hadn't worked with the debugger before and want to get a chance to use it. So in this like activity, we're gonna have y'all actually sort of wrap up what we went over with the first activity in the debugger, where you'll be trying to set a breakpoint in the line numbers class and answering these questions. I took out the first couple questions from last activity because I think you can answer those pretty easily with just code navigation techniques. But I do want to just first wrap up sort of the demo of what you can actually do with the debugger, just so you can then use these techniques in the activity right now. So let's go to update sidebar text. And what we wanted to do is just set a breakpoint here at width difference, okay? And we're going to run our debugger and hit the breakpoint, okay? And also at any point, if I'm going a bit fast, I think this was something I saw in the feedback, just feel free to raise your hand and ask me to repeat something or just show something again. I definitely don't want to speed past so that people can't follow along. All right, so you set a breakpoint by actually like clicking in the left tab, or left like sort of pane next to the line number. And then to actually get to the debugger, you'll click this run and debug option, okay? This is sort of what you'll be able to use to track everything going on in the debugger. I'll actually run the debugger by pressing the green arrow at the top here. And let me just make this bigger. So the breakpoint, again as a reminder, is where the execution is going to stop, okay? So we'll only actually be able to interact with the debugger when the breakpoint is hit. So based on like our understanding of the feature so far, the breakpoint is an update sidebar text, which is part of the line numbers class, right? So we will want to actually open up a new file, okay? This is, right now we're in the shell. The idle shell is what opens up when we start idle. We'll want to go to new file, and then we want to show line numbers. And then as soon as I press enter, so all I did was open up the new file, I press enter, and then when you go to idle, you'll see this, this spinning ball, and you'll actually be taken to VS Code to actually be in the debugger view, okay? So last time I talked about what some of these are. This, sort of step over command is gonna be what allows you to look at one line of code at a time, okay? And a thing to note here is whatever is currently highlighted in yellow, that line has not been run yet, okay? That's just, the execution has stopped before running this line. When you press this step over, it actually just only executes that line of code, and then it'll update any local or global variables, okay? And so you can keep stepping over it, and you can see the variables sort of start to form on the left. And anytime there's an actual like arrow here that you can see, this indicates that it's like an object with different attributes, okay? These are going to be very valuable to look at for like project 2 and beyond. You'll want to maybe explore these different variables to understand the types of these variables and then the different values within these, okay? I think we saw last time that you can see the value of previous end in the self variable. Does anybody actually know what the self like variable or self object is? Someone just want to like raise their hand and say it if they think they know. It's in Python. What does the self mean? Any ideas? Yeah, go ahead.
It's like a pointer to the instance itself.
Yeah, it's a pointer to the instance of a class. So what we have here is the line numbers class, right? If we go back to the Explorer, we can see in the outline. Right now we're in the line numbers class. And so when we actually have an instance of the line numbers class, we have, anytime like an object is created, we'll have just an implicit variable that is just called self, okay? And you'll actually notice whenever we have a class and then we'll have a method called init, okay? This is short for initialize or initialization. We'll always have this first parameter be self. This is just that variable we were talking about that is like a pointer to its own instance, okay? So when we do like self.previousEnd or self.editWin, anything that is like, you know, after the dot, after self is an attribute of that object, okay? So like editWin is an attribute of self. Same thing with when we're back in our debugger view here. All these things under self, like self.parent, self.previousEnd, these are all attributes of that line number object, okay? Are there any questions about that, what self exactly means? Okay, so let's keep going through this. You can keep stepping over, doing one line at a time, and then I want to get to this step into. So when you click on this, it'll actually take you to whatever method you were previously on, okay? So in that last piece of code, we were at line 354, self.sidebartext.insert, okay? And then I pressed this down arrow, and I was taken to this. It looks like we're somewhere in tkinter. I think that we encountered this last lecture. We're in the init.py file in the tkinter directory. But we have this insert that looks like it's responsible for inserting characters before the characters at index, okay? So that's just an example of showing you how we can use this step in, and then we can step back out to go to the initial line that we just stepped into, okay? So that's what step in and step out are responsible for. It'll help you sort of like zoom into a certain function to see what's happening, like, you know, under the hood, like more specific to just the method call. We want to see like what the source code of that method is. Okay, and then this red block or this red square here just stops execution, and then the instance that idlib was running on will close down. Okay, so let me actually collapse everything. Just close these. Okay. So now we'll have y'all complete this activity. There's a link to the activity here. It's actually a different link than the one from last time. So type this in 416-2 and then answer these 4 questions. You might already know the answer to them, but actually have it answered through the debugger so you can get the practice of setting the breakpoint and then running the code, okay? And again, these are all with the specific case of going from 9 to 10 lines of code in the line numbers. In the line numbers view. Let me show you what that. So answer all these questions in the specific case of going from 9 to 10 lines of code, okay? So,
The debugger, like,
Oh yeah, so that when you press run there, we're gonna go over this in the village. I think that's actually running some of the tests related to this. You're yeah. So you see this
right.
yeah, I don't know which
Keep setting to do it. Oh yeah.
yes, but okay, yeah, oh, so you know when you're running it, you were the first one?
Yeah,
Okay, that is, we're debugging a module on a file, and that's one of the settings. Try it. Yeah, do the top one. Oh, yeah, I did this. The version that right, so this is the interpreter that you're using. But when you it'll look for the idle lib directory that's in this interpreter, which means it won't be the same as the code base you're making edits to right now. So I actually don't even know if the breakpoint will get hit since you're making changes to the version created by in our Comprehension folder, not you know, for 1.12.2. So actually make sure you set the interpreter as the Python executable in the so yeah, that's okay. I think also in the end of the project you can just check that like it's an interpreter. But let's do the enter interpreter. And so now we just have to go to the Python.exe file that's in
You're Python.
directory.
Probably select the
Not in idle,
individual.
so now it will successfully
Yeah, you wasn't missing.
let's just scroll. I think yes, like oh, and then did so actually, let's just make sure that you I haven't updated.
That's not the truth.
You just do that.
And solely removed, so you can specify it.
Let me know. You want to run that?
So I just like instead of bring one add and then I just like count how many times that like so like that. Because like when it gets not this work for the yes.
Yeah, I think this. I do know what's happening here though is that this thing is running a Python file. It should say Python debugger one. And that's what should be in our Okay. Can you delete it? The outside. And can you open up the yes. Individuals. Alright everyone, let me just make a couple of quick announcements because there's more issues in running the debugger than we thought. So first of all, I think you could rewatch the podcast from last lecture. I think you can see like just the reminders of what you should have open, what you have to have your interpreter set to, and what your launch.json file should say. Make sure that when you're in this run and debug thing, it says Python debugger module, okay? The other thing it might say is Python debugger file or current file. It should say module because we're actually running the debugger on a module, which is like a set of files, okay? Which is the idle lib directory. So make sure it says this up here. You should make sure that you only have idle lib open, okay? Not the entire individual projects folder. This is specific to the debugger and also just in general. Every time you come to lecture, every time you do the project, have just the idle lib folder open because that's the extent of our workspace. We don't want all the other sort of files clogging up our workspace. And you want to make sure that your interpreter is set to the version of Python that we built, okay? So it should say, yours will probably say something, and then your individual projects dash, your user ID, and then /python.exe, okay? As long as you have those things set, like the run and debug thing is correctly showing, your run and debug is correctly showing module up here. If it's not, you might have to make sure your launch.json file is in the right directory. Make sure that this is in idle lib, not in individual projects. And then you should be able to see the options here for Python debugger module, okay? If there's still any issues, yeah, you can ask us, we'll walk around and help, or after the lecture, I think you can try just rewatching the podcast or coming to us. Okay, we'll do a couple more minutes with this. Yeah. Okay, so this is supposed to happen.
That's
So we have to use those options and
Yeah, right.
step over the line to go, or if you press
Wait,
play,
yeah,
it's now you want to go ahead because it'll basically jump over and right over. Yeah, it'll look like it's timing, but really what it's saying is that you have to handle it.
I have to like run the commands like I don't know why.
I think you just work.
Oh,
That
yeah.
might be good.
That is it. Get it works,
Maybe I'm just copy pasting this.
only one. If I had one,
I'll make
The Python also have Python. Oh, look, yeah.
I never remember a role thing.
This is also just like written out in Spanish. So you need like that's a reminder that's for you. Yeah, you should be yeah, okay, this should be max file, first line number. There
There's no.
But then you maybe
It's a tradition setting.
No, it's yeah.
Yeah, there's no function. It's yeah, it'll take you to somewhere else in the like overall C Python. Like we're using everything that we're using is like technology and individual projects. So anytime you step into something that's not in the idle thing, you'll probably have something here. That's a good question. I don't think we need and then I think you can step into, I think you can step into more. Yeah, there's several. Okay, I'm gonna yeah, then you can step out, or yeah, you can just step over. Okay, everybody, let's wrap this up because we want to get to the diagramming part of this lecture. Don't worry if you weren't able to get to all of this, but please do make sure your debugger is like set up and able to run. Hopefully, you know, it'll be something that's very useful for you to use in Project 2, okay? And it will be useful for you to use in Project 2. So if it's still not working, come up to us after class, come to office hours, and we'll get it resolved, okay? All right, let's see how people approach this. So, say we wanted to answer these questions. Where did people set a debugger or set the breakpoint that you were able to like successfully find the answers to this? Can anyone just let me know like the line number? Yeah. 338. Okay, cool. So if we do this, let me end the execution. So again, just to show the process again, I'll set my debugger first. I have my correct interpreter down here, and it's Python debugger module. And so when I run this, it'll open idle-lib. I'll do new file. And so it looks like here, if we have the breakpoint set here, we're hitting this as soon as we even open the new file, okay? Once we even open the editor. And also just, because this is a bit confusing, if it's like stuck like this on the spinning ball and it didn't immediately take you to VS Code, that's fine, that's normal. This is just telling us that the application is suspended, okay? That it's not running right now. To unsuspend it, we have to actually interact with the debugger. We'll have to click these options. Yours might not be right here. You can actually move it around to different spots, so you might have to look for it to make sure, you know, you can then click on it. So, okay, this is one option for the debugger. The reason that this might not be the best option for where to place the debugger though is that I'll have to like click play here, and then now I'll have to do window or options, show line numbers, and then when I press enter, I'll still be hit with, you know, this breakpoint. I'll have to press play again, and then I'll go back here, I'll press enter. It'll just, you know, I'll have to do this until I reach line 10, okay? So, are there any better, like any other options for where we might want to set the debugger? Yeah.
343.
343. Okay, awesome. Yeah, let's try it here and see. So I ended the last execution. I pressed the red square, but now I'm going to restart it with this as the breakpoint. Okay, at line 343. And now when I do it, I'm able to do a new file, and then I can do show line numbers. And then now I can actually go all the way to line 9 without having hit the breakpoint. But since the question was asking about how do we get from line 9 to 10 with the width expanding, this now only takes us to the breakpoint in the specific case that we want to study, right? So actually choosing the breakpoint is like a subpart of using the debugger. And to choose the right breakpoint, there's typically a little bit of code navigation or code reading that we're going to want to use to set the breakpoint most effectively, okay? In this case, it makes sense here because when we do a bit of code reading, we can see that first we calculate the width difference between the previous last line number and the new last line number, and only if there is a width difference do we jump to whatever's inside the if statement, okay? So this is a great choice for where to place the actual breakpoint. And so now we can start stepping through and answer these questions, right? So what is the value of new text? Let's just jump to this. New text is down here. So I think we have to step through, since this line, like new text equals, is actually like 4 different lines. We actually have to finish running through all of them before we actually see new text pop up here. But I think we figured this out in last lecture, that it's a \n and then the number 10, right? Or whatever the new last line number is. Let's get to this third question here. What would happen if you removed the \n in the new text definition? Was anybody able to get the answer to this question? Yeah.
Yeah, so the line number will just stay on the first line as if you remove the \n.
Yeah, so what would show up over here? Like, would it say 10 down here?
No, it will go up, like where the 1 is, that's where the 10 would be. So like, if I remove the \n and then I restart the whole thing, and then the line number will remain at the first line. It will just update the number. So I go for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay. Okay, so I think, okay, so first of all, let's break this down into 2 things. First, if we have this like hypothetical, that's what happens if we change the value of a variable. That's actually one of the really powerful features of the debugger. You can straight up change the variable values during execution while you're still in a breakpoint, okay? So all I did here was double click on this \n, and then I'm just gonna take away the \n so it's just 10, okay? So I just double clicked on that to be able to edit it. I'll press enter now. So now we can see that the new text value is 10, okay? I did this after it finished executing new text, right? It initially said new text is \n and then 10. If we just change it directly, now it's going to be like this for the rest of the execution. And I'm just gonna step over, I'll actually just press play so that if we press this play button, it just immediately jumps over wherever we had stopped and keeps running as normal. So once you press that play button, you can actually go back here. And now we can see what actually happens. I think there might have been some different change that you might have made to cause it to be 10 over here.
Oh no, it's more like I just restarted the debugger.
Oh.
I didn't know that you could change
so
it with stop. Yeah, while the debugger is active.
Yeah, so this one, you don't want to restart the debugger because then all the local and global variables will just be like reinitialized basically. So now we get this like weird case where it's saying 10 here, but really if we sort of think about what the actual code here is doing, since we just removed the \n, there is presumably still the 9 that is to the left of this 10, okay? We just didn't have the \n, which is an enter button or like a new line character, where it would have said like 9 over here, where it currently says 10, and then it would say 10 where my cursor is right now. But since we just took away the new line character, it causes this issue. But the weird thing is our cursor is still here on line 10, okay? So this is maybe a more, like, I don't know, silly example because we wouldn't actually have this situation where we change \n. The point of this is just for you to realize that you can actually change variable values mid-execution and see how the program would react. Okay, and then I think we covered this last time as well, but how many times is this with temp enabled text widget line run? And the answer is 2. I think I won't demonstrate that right now, but essentially you can set a breakpoint there, and then it'll get hit, and then you'll just keep stepping through, and you'll see that it'll eventually reach it twice. Maybe I'll do it very quickly. So we go to new file. I think it'll be immediately hit, and then we can step through it. We had initially started with it, we go back to it at the end, and then we jump over. It's kind of like the while loop, where we have to check the condition at the start. If it's true, we'll then check it again, and then we'll jump out of it or break out of it, okay? We're gonna go over what the with keyword means more. I think we talked about it a bit last time, but there's some sort of like advanced Python features in this code base that we're gonna talk about next lecture or in 2 lectures from now. Okay, this last one is, does the code update the sidebar width even when the show line numbers option isn't enabled? Can someone let me know what they did to answer this question? Yeah.
So I said that it does, and I set the breakpoint to line 345.
Line 345. Okay.
Yeah.
Yeah. Anything in this like thing would work.
Yeah, and then I just ran it, and it ran the code, or it went to the breakpoint, even though I didn't have the line.
Yeah. Yeah. Awesome. So just to restate that, we set the breakpoint somewhere here in this width difference, and we want to actually check this condition, right? We want to see when the show line numbers is not enabled, does the code to replace or to update the sidebar width still run? And the answer is yes, but the way you would actually solve that is setting the breakpoint in the same spot as last time, 343, 344, 345, all of these are fine because they're within this if statement. And then what we want to do is actually trigger the breakpoint, right? But we don't want to, what we were doing before is first doing options show line numbers, and we were going down to line 9. Here we're curious of what happens if we don't have show line numbers enabled, right? And so I think, okay, let's just count this. This is at 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I press enter here, it still takes me to the breakpoint, okay? So this is maybe like, I don't know if this is like I don't think it's a fault in the system basically, but it does seem like we don't actually, oh, maybe we do need to be running this because now if I press, okay, so if I press play now and then do something like show line numbers, I guess it should already be saved. So actually it makes sense why this is running even when it's not enabled, but it's kind of interesting to see that this is still running even if the user can't see it, right? Because there's the case where the user might eventually enable it, and so we'll need to have done all those operations for every new line so that we can display it to the user correctly, okay? Did that make sense to people? Just this use of the debugger, some of the different things we can do. I think the main takeaway here is that you can actually edit the variables during runtime, you can track the variable values, and of course we want to be using all these different features of the debugger. I know that was a bit fast, but we have spent a lot of time on the debugger now, so maybe you can re-watch part of the podcast to go over, like in last lecture and this one. And there's also an exploration activity. I think a lot of y'all haven't used this IDE-based debugger, so this will be really helpful practice. This is the second to last slide in today's lecture slides. Please try to get it. So these are pretty informal, okay? The point of these exploration activities is for you to just get a chance to practice more what we're going over in class outside of these in-class activities. You can get this done like maybe by Sunday night or Monday night, maybe before next lecture if possible. The goal here is just for y'all to learn. Even if you don't submit it in the next day or two, maybe by next lecture, we'll count all the people that have done it, and that'll be, the credit for the exploration activities. There's only going to be a few of these throughout the quarter. I think together it'll be about 5% of your grade, okay? So just complete it. It doesn't have to be based on correctness. Just use this link here.
What's the one last session?
Last lecture, it was going to be this one, but we didn't get time to finish the
Oh.
debugger, so it's still just this one, okay? There's only one exploration activity out. And just try to put some effort into the responses. We'll just make sure that it actually says some, correct stuff to make it clear that you put in the effort. Okay, this is more for helping you. It doesn't really impact me. So please, put the time in, and I think you'll be able to. Awesome. Okay, let's get to diagramming. Okay, so diagramming is a very important part of program comprehension, because we can use diagrams to help us understand high-level relationships between parts of the code base. But diagramming is also very useful for project and code management. Okay, we want to create and maintain good diagrams so that for the same reason, when new people are coming on to work on a part of the code base, it's very clear to them what sort of the extent of the code that they're dealing with. Okay, so there's a couple tools here that I want to share for how to create diagrams. I would recommend using them and installing them. I think after today's lecture, it's sort of up to you whether you want to use these softwares to create diagrams, or you want to just create it on your own, or handwrite it and then scan it. You'll sort of see the different options that are available in the different types of diagrams. But here's one I want to share, PyEndSource. This is also an open source project, but it's a pretty cool way to sort of auto-create diagrams, okay? So let me just show the tool first. So you can follow the link that's in the slides to actually download it. I'm just going to open it up because I already have it. Essentially, the way that this works, it takes a second to actually open up. It actually converts Python code to diagrams. So you actually just have to upload some Python code that you want to create a diagram for, and it'll automatically create it by understanding the relationships between classes, what are all the methods that are within a class, and what are all the variables within those methods and within those classes. So when you open it up, you can go to File, or actually sorry, I think it's import Python code under File, and then you'll actually just want to choose whatever file of interest you want. So let's just do the format one, okay? So say you wanted to create an image or create a diagram that covers how the format.py file works. It'll show you sort of the different classes and the different variables and methods within the class. Right now, it's actually not showing any relationships between them, which is pretty interesting. I'm not sure why. Maybe there aren't relationships between these different classes. And unfortunately, I can't zoom in on this because this is an unpaid version of PyEndSource that I have. When you have the paid version, you can actually zoom in and do a bit more customization, okay? But I just want to show you that these things do exist, because a lot of times in big projects, there will be auto-generated documentation or even auto-generated diagrams to sort of limit the amount of work that a developer has to do to sort of create the diagrams on our own. Okay. Admittedly, I was looking this up a bit online. The software for Python code to diagrams is pretty weak. This is the most up-to-date and the most, I guess, advanced, freely available software for doing this. It was last edited in the open source community in 2019, okay? The other ones were 2012, 2009, so they're not very up to date or available for us to use well. But this one does work pretty well, so if you want to use this for some of your just understanding, maybe you don't want to actually have your final diagram that you submit be created through this, but just to get an understanding of the different files or the different classes that are available across files, you can just use this on your own to see what are the different relationships that I might need to know. Okay. I'm going to actually move on to just the types of diagrams, okay? Actually, let's do, Jared, you want to do your part first, and then I'll cover the types of diagrams. Huh?
Go ahead.
Oh, okay, I'll go ahead. So I'll just spend a couple minutes on this. There's a lot of different types of diagrams, okay? There's two that we're going to go over are UML class diagrams and use case diagrams, okay? For each one, let me actually show, okay. So UML diagrams, UML class diagrams are sort of meant to show the relationships between a bunch of different classes, okay? So this is actually, actually I'm not going to show this right now. Let me, okay. So a UML class diagram is meant to show relationships between different classes that are in the code base, okay? This is a list of the different types of relationships that exist between classes, okay? So there's like an inheritance relationship. Y'all might have heard of inheritance before, where you have like a parent class and a child class that sort of uses a lot of the same methods or fields from the parent class, okay? There's a realization relationship. This is when you have like an interface and then something that actually implements or realizes the interface, okay? Then we have dependency. Dependency is when like we have some class and it is dependent on some other class, or like it uses some other class as a component, okay? So that'll be like, we have the example here. We have a mechanic class, which is just like the person, the mechanic. And then they will have maybe some field that uses another class called tool, okay? So the mechanic class is dependent on the tool, which would be like the other class, okay? Then we have aggregation and composition. I know I'm going through these a bit fast. I just want to give like a high level understanding of it. There's a couple of different links that you can visit at the bottom here as well. And then you can see the actual way that this is depicted in a diagram. But I'll go over aggregation and composition. These are actually quite confusing, and it took me a little bit of time to understand the difference. So aggregation is when like a bunch of different classes are a part of like a superclass, or like a parent class, I should say. So the example that works here is like, oh, and importantly, in these relationships, there's not a parent-child relationship between the classes, okay? So you can think of like a course class, and then like 50 students, right? The students are going to be a part of the overall course object, okay? But we don't have the parent-child relationship, and one way to realize that something is a parent-child relationship is if you delete the parent or remove the parent, the child will also like not be able to exist anymore, okay? That relationship is not present in this course and student example, because if you remove the course, the student objects can still sort of like be there on their own, okay? They're not necessarily a part of that class, of that course, and only that course. That's aggregation. Then there's composition, which is like the necessary or like dependent components of the parent class, okay? So this example of like hand and leg are part of a person. When you don't have the person, the hand and the leg suddenly don't really have meaning anymore, okay? Again, this you can probably imagine a world where there's like a hand, and hand can belong to multiple persons, okay? This is maybe like a bit of a simplification or like a specific case, but the idea here is that composition, the difference between composition and aggregation are when is the existence of this parent-child relationship, or in other words, life cycle dependency, okay? If there is a life cycle dependency, then there is a parent-child relationship, okay? Because the existence of, the child depends on the existence of the parent, okay? Yeah, question?
How does dependency relate to aggregation and composition? Like does aggregation and composition both produce dependency?
Yeah, okay, great question. So the question is, how does dependency relate to aggregation and composition? So this is a slightly confusing part of these relationships. It's possible that multiple of these relationships exist between two classes, okay? Like, for example, association is actually just more of a general term to describe that two classes are related to each other. But there'll be an association between classes and also like a composition relationship, okay? So you can probably find examples in the idle code base where maybe more than one of these might exist, but you might be in a position where you'll just have to choose what is the best representation of how to explain the relationship between these two objects, okay? And that might even depend on like what specific purpose you're creating the diagram for. Like if you're creating a diagram where, there's like a parent class and a child class, and it's in the context of, making changes to the parent class, you might want to emphasize that it's, a composition relationship, because if we make some change or deletion to the parent class, it would impact the child class, okay? So the point here is just that there might be multiple of these that can reasonably fit the relationship between two classes. You'll just be in a position as the diagrammer to choose whatever best represents how you want the diagram to come across, okay? And I think there's also a lot of online resources available for this. Something that helped me a lot was just looking up examples of each of these, and I think the examples help the most with understanding what exactly is a composition relationship, what is dependency, what is aggregation, etc. Are there any questions about this? So the reason I brought up all of these is because in a UML class diagram, depending on the relationship, that is how we actually represent a relationship between certain classes. So if there's an association, we just represent that with a line connecting the two classes, okay? If it's an inheritance relationship, class 1, which I think inherits from class 2, you have the arrow pointing to wherever, the arrow is going to the parent class, and the line is from the child class, I believe. That might actually be backwards, but you can check in this. And when you use the PyN source and stuff like that, it'll automatically create these relationships for you. So you won't have to do too much thinking about that. But if you create it through like Google Sheets or something like that, you will then have to recognize the relationship between the classes and then do it on your own. Yeah, it looks like in the inheritance, the subclasses are where the lines are, the arrow goes to the superclass. So, okay, now Jerry, let's have you go ahead and just talk about more like ad hoc diagram.
So, well, we've seen ways to draw diagrams, ways to automatically generate diagrams, and as Anshul mentioned, there are two primary purposes why we would create a diagram. One of which is, of course, to leave documentation, right? We have a very complicated code base with 10,000 lines of code. We want to make sure you have a way of documenting the relationships between different classes, so that someone, when you inevitably get fired by Elon Musk, someone comes in and then can look at your diagrams and figure out, where do I pick up? Right, this is how the code base works, and then, or you can just burn them because screw Elon Musk, firing you. But the more important point that I'm trying to make here is using diagrams, and in fact drawing diagrams yourself as a way to facilitate understanding of a very complicated code base. So this is a part where I may draw from some of my personal experience, and which you will later see in later slides. I guess I'll first motivate this idea of sketching your own diagrams. Why is it necessary? Why can I just not stare at my code? And I tell my CSE 29 students, don't just stare at your code. That's just the silly thing to do. Always do something with your code. Either run it, or make a diagram of it, something like that. So sketching your own diagram. So I'll talk about this maybe slightly philosophical argument from my own perspective, right? I'm 25 years old. I know how my brain works and where it's good and not good at things. So this is my brain, right? Compare it to a computer. This is my brain. It has some amount of processing power, probably below average from my experience with math classes. So I'm not very good at thinking, but I can think reasonably well. Now, what I'm really terrible at is remembering what I just thought about, or holding complex ideas in my head, okay? And so you can think of me as someone with an Intel i9 processor, Intel i5 processor in my brain, but only about 1 gig of memory, okay? But what do you have available to us? If you've taken an operating systems class, if you know anything about modern data system, you know that hard drives are cheap, okay? Persistent storage is cheap. So instead of trying to hold everything in your brain, or instead of trying to hold everything in your memory, unless you're a cache server, just write it down. Write it down on pen and paper. So put it into your hard drive so that you can always come back to it. And for me, this is a personal limitation. Right? Even when I'm working on a small bit of code, I still need my pen and paper to make sure I can understand things. That's just because I have a small brain. But all of you, have very large brains. But your large brain might still not be big enough to hold an entire code base. So last summer, this is where I'll draw from some personal experience. Last summer, I was interning at Qualcomm, and the first project I was given was sorting out this bit of infrastructure where they were using to control running firmware validation test cases or whatever. It's not important. But it's around about 10,000 lines of Python code. Maybe less, 5,000, I'm probably exaggerating. But okay, it took me a while to understand how things connected to other things before I was able to start even making my first line of code change without having everything completely crash and burn. How long do you suppose it took me to draw a diagram of the code base where I was reasonably confident? I was like, oh, this is probably how it was. How long do we suppose it took? It was only a one-page diagram, but...
How long did you work there?
3 months.
2 months?
2 months for a diagram. I'm not that slow.
After the big piece.
Yes, no, I get that. But okay, so that project took me around about a month. But the first half of it was just coming up with a diagram so that I can actually understand the code that I was supposed to deal with. So my point is the diagram is really a way to get around our own, really, I must insist, it's a biological limitation because we as humans, we're not just able to hold a huge code base in our head, especially when we're trying to figure it out. So, you figure out a bit of it, and you put it down on a piece of paper, and then the next day you come back, all right, let's see the things that are around this class, right? And then we continue to expand on what we already have. Eventually you come out with a complete diagram and a complete understanding of the code base. So that's what this class is, right? Working with large code bases. I won't actually, unfortunately, be able to show you that Qualcomm diagram because I signed an NDA. I was supposed to actually just shred my notebook, but I don't want to. So this was from a previous job. So this is an example of what diagramming could look like. So obviously, Anshu just introduced the UML diagram and what was the other case? Use case diagram, yes. But when you're actually just sketching things out on a notebook, you probably won't necessarily need that level of rigor or standard in terms of how to represent things. Because in the end, if you're the one drawing it, you can pretty much remember what you did. But as you can see, this is after many iterations, and you can see that I'm just squeezing things into the corner here. But the idea is you open up the code base, you find an entry point, right? Because there's always an entry point. The fundamental thing about tackling any CS problem is you need to know where to start, okay? If you're looking at 20,000 lines of code, or if you need to write 20,000 lines of code, you need to know where to start. And the beautiful thing about diagramming is you can start anywhere. Just pick a point, like suppose I started here, you can build back out, you can build back up to the top of the logic, and you can go down and see how the logic goes deeper into nested classes. So obviously my handwriting is terrible, so I transcribed it here. So this is one of the, I guess, not so much a UML diagram or a use case diagram, but really just random scribbling. So you can see that there's a web page that I'm trying to look at. It's called an agenda session, and I wanted to make like some sort of video player with logic controlling what is shown under what conditions. So this was me being given absolutely crap existing implementation, and I was trying to figure it out. And here's maybe a point that I missed earlier, is having a diagram of things helps you understand where the inefficiencies lie, or where the redundancies, or where things can be cut down or simplified. A diagram helps you do that. So if you look at this is basically what I wrote down. You can see that we begin with a page, and we first ask the question, is this session, a session is like a Zoom call session, whatever, it doesn't matter. Is the session locked? So you do that, and then if it's locked, you show an overlay, And then based on whether or not it's a live stream or if it's a video, we'll show different components. And then there's all these different things going on. But you don't have to understand this, of course. And this is technically proprietary and confidential, so please don't tell my old boss that I'm showing this in lecture. And so you can see that there's a lot of nice and layered, incrementally developed code, right? One thing building on top of another. It's very simple, small components. Whereas on this side, you have one big ass component that handles everything with like 500,000 if conditions in it. So when you see that, you say, well, I need to split this up. So having this sort of thing, when you're looking at a bunch of very abstract code, you can extract the essence of that code onto a piece of paper, and then you can see, right, this side is much better, and this side, well, I just have one giant thing. And also, with this kind of diagram, you can see when things are supposed to share logic, right? So if you can identify common components of the code, that's also a good way of thinking about how your code should be organized. Because we've talked, Anshu has talked at length about how to navigate your code base, how to use a debugger, how to use VS Code, keybinds. Eventually, all of that is in service of coming to an understanding of the code that is in front of you. And as you, either your brain is so huge that you can hold everything in your brain, or you like me, have a relatively small brain, or sorry, a regular sized brain, and you need a pen and paper to figure things out. Well, the navigation skills that you have obtained up till now in lecture is basically the tool for you to arrive at diagrams like this. So this is, has anyone here heard of Django? Not the movie, but the web server framework. So this was me trying to understand a third-party package for Django for sending scheduled tasks. Sometimes there's a mass email campaign at 2 a.m. to all our users, and that's scheduled for 2 a.m. And every 15 minutes we do this. So there's a scheduling system, and this was me trying to understand a bit of code there. So again, this is like me starting with this one class called the database scheduler, and then a lot of, again, no pressure on understanding what I was here. I'm just trying to demonstrate what I did. So there are runtime things in Python. That's kind of the thing that is not so nice about Python, because a lot of things are decided in runtime, right? And that's partially the limitation of any static code analysis tool, like the PyN whatever thing, is that it's not able to run the code and then figure out, oh, this thing is going to be this, that thing is going to be that. Python is a flexibly typed language, right? So sometimes the very type of a variable can only be determined at runtime. So you need to use all of the skills that you have obtained up till now, running the code, using using VS Code keybinds to jump around code is a static way of analyzing the code, and running the program and using Debugger is a dynamic way of understanding the code. So both of these, particularly for Python, are going to be incredibly useful because, as I said, Python code, sometimes the only way to understand it fully is to run it. So this was me after putting a crap load of print statements. I wasn't aware that, oh, there's a Python debugger that I can hook up to VS Code. So thanks, Anshu, for teaching me that. So this was me putting like 500,000 print statements in my code. I'm figuring out, oh, this is this at this point of execution. But the main idea is, again, and I reiterate, find the starting point and start building a diagram of how the system works, right? Let's just say, I'm going to look at this class, I'm going to run the program, and starting at this class, how are things evolving, right? What class do I go to? What method do I invoke? Things like that, you just put into your diagram. And then at the end of the day, you come back, and then you have a better understanding of it. Now, unfortunately, I can't show you the Qualcomm diagram, which is absolutely beautiful, but let's do the activity now.
Yeah, I'll just go over this quickly. So we're going to wrap up with this activity, but we're going to have you all actually, so hopefully you have something to write with. If you don't, you can use like Google Sheets or just something on like Figma or something to actually create these documents, create the diagrams. So I just want to wrap up what Jerry said here. I quickly went over a UML diagram, and there's something called a use case diagram I'll talk about more later. The point of diagramming is not just to be so formal and like present your understanding very succinctly to somebody else. It's also just a tool for you to do some informal like understanding or note taking. Okay, so in this like activity, we want you to just sketch out something that will be helpful to you in understanding the code in sidebar.py. Okay. So specifically, draw a diagram to show the relationship between base sidebar, line numbers, and shell sidebar, okay? And there might be relationships between these, there might be a couple external dependencies of each of these classes. So during this, you'll want to use some code navigation. You might, maybe the debugger, maybe some experimental code changes, but take the next like 7 minutes to draw out your understanding of how these 3 classes work, okay? And at the end, we'll just like collect all the diagrams, so do try to like make some progress, and then we'll just see what people sort of come up with. You said it right. This is the only pen I have. Do any of y'all have something to write with? Tutor?
I have, yeah.
Thank you.
You want to do the pen?
Oh, yeah.
Oh, that's me. Okay, I realize it.
Since we're running a bit lower on time for the activity, you can maybe just focus on the relationship between those 3 classes and how those actually relate to the ultimate application. Like what do each of those sort of classes do, and what's the relationship between them? All right, everybody, we're gonna wrap up now. I'm not gonna collect the diagrams. Y'all can actually keep that on your own.